All right, so let's take a look here about solving some ratio problems. Sometimes when we're given two ratio equivalents, we're not given all the numbers. We're just trying to solve for an unknown number. So in essence, this is an algebra problem because we're solving for an unknown. In this case, we're given two ratios here. 5 to x is equal to 40 to 56. So we know that these two are equal because it tells us there's an equal sign there, that those two ratios are equal. So what we need to realize here is that we have a connection. And the connection is going to be between term 1 on this side of the equation and term 1 on this side of the equation. So the question is what is the relationship here? In other words, what is the multiple or the factor that is connecting 40 and 5? And in this case, it would be the number 8. So in other words, if I take 40 and divide it by 8, it is going to equal 5. Conversely, I could take 5 and multiply it by 8, and it would give us 40. So because we know that 8 is the magic number, we can simply say, well, on this side here, this term 2, all we have to do is divide that number by 8 to give us our unknown. And so if we just take 56 and divide it by 8, it is going to equal x. And in this case, x equals 7. So if we were to take 7 and plug it into this number here, we can say that 7 times 8 equals 56, and therefore we have solved our equivalency issue. This whole concept of algebra is important because we're going to be moving into some other problems here where we're actually going to be using algebraic expressions in order to solve problems with ratios. I'll show you an example here right away. All right, let's take a look at this problem from the textbook. This is a crude drawing, forgive my artistic capacity here. But anyway, we've got a picture of a father and daughter, and in the photograph, you can see that the father's measurement is 8 centimeters and the daughter's measurement is 6 centimeters. That's their size in the picture. And we know the father's actual height is 180 centimeters. But what we don't know is the daughter's height. So we're going to use the variable h to represent the daughter's height in centimeters that we haven't yet figured out. But what we are given is we are given a ratio by the photograph. And the ratio states that the father's height, 8 centimeters, he is 8 centimeters tall to his daughter's height is 6 centimeters tall in the picture. And we know that this ratio has to be equivalent to the actual height of the father, which would be 180 centimeters, to the daughter's actual height, which we don't yet know, which is h. So now, going back, we know that this would be, we're dealing with term 1, and term 1, and term 2, and term 2 to find our ratio equivalent. Problem we have here is that this number 8 does not divide evenly into 180. So what we're going to need to do is we're going to need to find an additional ratio equivalent that will divide evenly into 180. So in this case, we're going to choose to reduce this. 8 divided by 2 is 4. 6 divided by 2 is 3. We can say that 4 to 3 is the equivalent of 180 to h. And we do know that 180 divided by 45 equals 4, or 4 times 45 equals 180. So now we've got our magic number in order to solve our problem. Let's take a look here. So if we've got 4 to 180, we know the magic number is 45. We can simply state that, well, 3 times 45 is going to equal h, or h divided by 45 is going to equal 3. Well, this is a pretty easy one to solve. If we can just say 3 times 45 is going to give us our answer of h, and in this case, our answer is 135. But just to demonstrate from an algebraic perspective, okay, if we were to also rewrite that equation, we could say 3 is equal to h divided by 45, because we don't know that yet. And if we want to just do get h by itself, we simply multiply by 45. And in this case, we multiply what we do to one side, we do to the other. And we had our cancellations here. And h is equal to 135. All right, so that's the first example. We're going to take a look at an example that kind of goes the other way. Instead of reducing a ratio down, it's going to be finding a multiple going up. All right, this is a little bit trickier one. So what we've got here is we've got the bike tire. So basically what happens is every time you turn your pedal around full revolution 3 times, your back wheel will actually rotate 7 times. So we know that our ratio is 3 pedal turns to 7 rotations of the back tire. So what we're trying to figure out is, what is the ratio for 2 pedal turns? So if you only crank the pedal around twice, how many times will the back tire turn around? So what we've got is we've got a basic ratio here of 3 to 7 equals 2 to, we'll call it t, for turns, because we don't know how many times the rear wheel will turn around. So we've got ourselves a little bit of a problem here, because we can't reduce anything down. If you compare this term here, term 1 to term 1 here, it's very difficult to find a relationship. So what we're going to have to do is we're going to have to do kind of like what we do in fractions by finding a common denominator. In this case, we need to find the lowest common multiple of 2 and 3, which we know to be the number 6. So the lowest common multiple here is 6. So in other words, we are going to have to multiply this one here by 2, and we're going to have to multiply this side by 3. Okay, so let's take a look and see what that looks like. Okay, so what we're going to do is we're going to first find the equivalent here. So now we're going to take 2 and multiply it by 3 to give us 6, and 2 to 7 is going to be 14. And then what we have here is we're going to have 6 times 2 equals, well, 3t. So now we have this situation where it is the same here. The question is we've got our algebra problem now, and we need to get t by itself. So what we can say is that 14 must equal 3t. And so solving for algebra, all we have to do is get t by itself. So if it's 3 times, we do the opposite, which is divide both sides by 3. This cancels out. 14 divided by 3, well, if we reduce that down, it's going to be 4 and 2/3. So in other words, the bike wheel will turn around a total of 4 and 2/3 for every 2 pedal rotations. Okay, the next question we're going to do in the next video is going to be based on how to solve a problem when you're dealing with a 3-term ratio.